Hi friends, very good morning. Welcome to Anu Academy. Today's class in our channel we are going to discuss production technology. Okay, so this subject is useful for your upcoming semester examinations. So in this subject we are going to discuss with core. Okay, so let us start today's class. If you are not subscribed to our channel, please subscribe our channel. Please like and share our channel. Okay, now we'll start discussing core. Refractoriness or thermal stability of core can be increased by giving a thin coating of graphite. Core sand mixture is ramped by jolting, squeezing or blowing by means of suitable machine. Okay, so coarse sand with large grain size mixed with molasses is used for core making. Types of cores: according to the state of the core, green sand cores not dried before using, dry sand cores, oil sand cores, linseed oil, loam cores and metal cores. Now we'll see here core sand. Core sand is a variety of silica sand, rock sand, river sand and seashore sand, commonly known as sharp sand, capable of withstanding high temperature, resisting the penetrating action of the molten metal. Core prints. A core is a body made of refractory material which is set into the prepared mold before closing and pouring it. For forming the holes and recases, projections, undercuts and internal cavities. For supporting the cores in the mold cavity, an impression in the form of a recess is made in the mold with the help of a projection on pattern. This projection is known as core print. Okay, so if you are getting a question regarding core, all these things you have to write in your answer sheet, then only you will get good marks, because it is a theory subject, so you should explain in a systematic manner, then only you will get in a good marks. Next, core boxes are used in foundry in connection with molds when holes or internal shapes are required. Okay, now we'll start discussing molding sand. Properties of molding sand: permeability, allow gases to escape easily from the mold; strength or cohesiveness, holding of together of sand grains; refractiveness, ability of the molding sand mixture to withstand the heat of melt; and next is collapsibility, molding sand mixture to decrease in volume. The sand should have low coefficient of expansion. So types of molding sand. According to the clay bonding material, natural sand contains sufficient amount of binding clay. Okay, natural sand, that is. Next, here no more binder is required to be added in natural sand. Synthetic sand, artificially compounded. According to their use, green sand green sand is natural. Silica sand with 20 to 30% water from 6 to 10%. Small size castings of ferrous and non-ferrous. These all these things comes under the green sand. Next, dry sand. Moisture from the green sand is evaporated by drying or baking. Greater strength, rigidity and thermal stability, large and heavy castings. Loam sand, 50% of clay contains large grey iron castings. It is used for large grey iron castings. Facing sand, high strength and refractiveness. Next, parting sand, clay free silica sand. Okay, parting sand is clay free silica sand. Okay, next we will discuss cope and drag separate without clinging. Backing or floor sand, it is black color; core sand and oil sand. Okay. Now composition of the green sand: silica is up to 75%, clay is up to 8 to 15%, bentonite is 2 to 5%, coal dust is 5 to 10%, water is 7 to 8%. Now most important topic is sand testing. In order to meet the requirement in order to meet the required level of accuracy and surface finish of castings, the molding sand should be of proper quality. Fineness test or sand grain size test, permeability test, strength test, moisture content test, clay content test, mold hardness test. If you are getting a question regarding the sand testing, all these things you have to write. Okay. Now we will see here fineness test, grain fineness number, it is GFN. Grain fineness number GFN is equal to sum of products, right? Sum of products by sum of percentage of sand retained on each sieve and pan. Okay, so summation MIFI by summation of FI. So MI is multiplying factor for ith sieve and FI is amount of sand retained on ith sieve. Okay. Next, permeability test or porosity of the molding sand is the measure of its ability to permit air to flow through it. It is measured in terms of permeability number P. So P equal to V into H by P into A into T, right? So V is volume of air equal to 2000 centimeter cube. H is height of the sand specimen, that is 50.8 mm. So that is 5.08 centimeters. So P is air pressure. Air pressure is 10 grams per centimeter square. So A is cross sectional area of this sand specimen, that is pi by 4 into this 5.08 square. So that is around 20.268 centimeters square. Okay. So if you are getting a question regarding this sand test, all these things you have to write. Then only you will get good marks. Next, see here, T is time in minutes for complete air to pass. So P is 2000 into 5.08 by P into 20.268 into T, that is equal to 501.28 by P into T. Okay. Next, strength test. Okay. Next is strength test carried out on the universal sand strength testing machine. Compression, shear and tension. Okay na? Next, moisture content test. Moisture content may be determined by loss of weight after evaporation. Calcium carbide to measure the moisture content. Sample of 50 grams is dried at a temperature of 105 degrees centigrade to 110 degrees centigrade for 2 hours. Okay, that is happening under moisture content test. Next is clay content test. The clay content of molding sand is determined by dissolving or washing it off the sand. Next, mold hard test, similar to the Brinell hardness test. Okay, so that's all friends for today's class, right? If you have not subscribed our channel, please subscribe our channel. Thank you very much. Thank you for watching.